Hey everyone, welcome back to the Cyphertech Insights channel. Today we're going to break down the concepts of IP addressing and subnetting. These are fundamental topics in network management, and understanding them is crucial for anyone working with computer networks. Let's dive right in. IP addresses are like the home addresses for devices on a network. They allow computers, smartphones, and other devices to communicate with each other. But what exactly are IP addresses and how do they work? Let's start with the basics. An IP address is a unique identifier assigned to each device on a network. There are two types of IP addresses, IPv4 and IPv6. IPv4 addresses are 32-bit numbers usually represented in decimal format like this, 192.168.1.1. IPv4 addresses are divided into 4 octets, each ranging from 0 to 255. This gives us around 4.3 billion unique addresses. However, with the growth of the internet, IPv4 addresses are running out. That's where IPv6 comes in. Visual graphics showing an example of an IPv6 address, for example 2001 0db8 85 a3 00000008a2e 0370 7334. Host. IPv6 addresses are 128-bit numbers represented in hexadecimal format. They look like this: 2001 0db8 85 a3 00000000 8a2e 0370 7334. IPv6 provides a virtually unlimited number of addresses, solving the problem of address exhaustion. Visual animation showing the structure of an IPv6 address. Host. An IPv6 address is divided into 8 groups, each containing 4 hexadecimal digits separated by colons. Here's how it breaks down. The first group identifies the network prefix. The subsequent groups can define subnets within the network. The last group identifies the specific interface on the network. Visual graphic highlighting each part of an IPv6 address. Host. Let's take a closer look. The first 48 bits are the global routing prefix, which is assigned to an organization. The next 16 bits are the subnet ID, used to identify subnets within the organization. The last 64 bits are the interface ID, which uniquely identifies a host on the network. Visual animation showing how IPv6 address space is divided. Host. IPv6 not only increases the number of available addresses, but also introduces new features like simplified address auto-configuration, improved multicast routing, and enhanced security features. Transitioning to IPv6 is essential for the future scalability of the internet. Next up, we have subnet masks. A subnet mask is used to divide an IP address into 2 parts, the network part and the host part. For example, the subnet mask 255.255.2550 indicates that the first 3 octets of the IP address are the network part, and the last octet is the host part. Alex cipher. This helps in identifying which part of the IP address belongs to the network and which part identifies the specific device within that network. Subnet masks are essential for efficient IP address management. Subnetting is the process of dividing a larger network into smaller, more manageable subnetworks or subnets. Why is this important? Subnetting improves network performance and security. By segmenting a network, you can reduce traffic congestion and limit the broadcast domains. For example, in a large office, subnetting can help isolate different departments, ensuring that network traffic from one department doesn't interfere with another. This also enhances security by containing potential network breaches within a single subnet. Let's go through a simple example of how to subnet a network. Suppose we have a network with an IP address of 192.168.1.0/24. The /24 indicates a subnet mask of 255.255.255.0, which means we have 256 IP addresses available. To create subnets, we need to borrow bits from the host part of the IP address. For instance, if we borrow 2 bits, we can create 4 subnets. Each subnet will have 64 IP addresses, but remember, the first address is the network address and the last is the broadcast address, so only 62 are usable. Here's how it looks. Subnet 1, 192.168.1.0/26. Subnet 2, 192.168.1.64/26. Subnet 3192.168.1.128/26, Subnet 4.192.168.1.192/26. Each subnet has its own range of IP addresses, allowing for better organization and management. And that's a simplified look at IP addressing and subnetting. By understanding these concepts, you can effectively manage and secure your network. Thanks for watching, and don't forget to like, comment, and subscribe to the Alex Cypher channel for more tech insights and tutorials. If you have any questions or topics you'd like us to cover, drop them in the comments below. Until next time, stay safe and secure.